Hi, fourth graders. Hope you're having a good day so far. We're back with a new number talk for you today, and we have a very special guest. Mrs. Rex from Emerson is going to help us with her thinking today. So I'm going to say hi to Mrs. Rex.
Hi, Courtney. Hi, fourth graders. How are you guys doing? Good afternoon.
All right, so Mrs. Rex is going to help us with a number line problem actually for our number talk today. So what I've done is put up some decimals and fractions on the board with a number line, an open number line, and Mrs. Rex is going to help us with her thinking about where these numbers should go and why. Okay? All right, you ready, Mrs. Rex?
I'm ready.
Okay, whenever you're ready, go ahead.
Okay. Well, Miss Farrell, when I start a number line like this, and I look at the fractions and decimals that you posted, I know from looking at them that none of them are greater than 1. So I start my number line with marking off each end with a 0 and a 1.
Good idea.
Then I think of the benchmarks, and I think of the benchmarks of 1/2, and I go between that number line, and I make a line right in the middle. And then I also like to make a 1/4 and 3/4 mark too, because in my head I know that 1/4 is in the middle of 0 and 1/2, and between 1/2 and 1 is 3/4. Okay?
Got it.
And another thing I like to do is think about those as, like, if I think of money, I know that, a $50 is 50 cents or 0.50. 3/4 of a dollar is 3/4 out of 4, which is 0.75. And 1 represents 1 whole dollar, or 100/100ths pennies. So that's how I'm going to look at it when I'm thinking about the decimals and fractions.
Okay.
So now, when we look at 0.5, I know that that's exactly in the middle at 1/2. So above the 1/2, you can mark it 0.5, because 0.5 is 50 cents or half of a dollar, or 0.5 plus 0.5 equals 1.0 when we add those.
Excellent.
When I look at, when I look at 1/3, I use the benchmark and think that 1/3 is closer to 0/3. However, 1/3 is 0.33333 as a decimal, and 0.15 will be less, Miss Farrell. So 0.15 would have to go before the 1/3.
Okay.
So do you see where you put 1/4? Okay, so if I compare 1/3 and 1/4, and I look at the denominator, 3 if of pieces of a whole is less than 4 pieces of a whole. So 1/3 would have to be actually greater than 1/4, and you're going to go a little past the 1/4 mark point to mark 1/3. Right around there.
Right around there? Okay.
Where your marker is showing right now.
Okay.
That would be 1/3, because that's greater than 1/4.
Okay. And if we look at that, is it about a third, it looks
It's
like?
broken into thirds. Again, we could do a double number line if you wanted below and show them, but that looks good right around there.
Okay.
Then when we look at the 0.15 is 15/100ths, right? 1/3 is about 33/100ths. So 0.15 would have to be less than 33/100ths, correct?
Correct.
So 15/100ths has to be less than that. Now it's going to be less than 1/4, because 1/4 out of 4 is 0.25, 25 cents, right?
Yes.
0.15 has to go below 0.25. So 0.15 will be closer towards the 0 than 0.25.
About there.
About where it is. Well, think about, move your hand one moment. Okay, if you think 0 to 0.25, if that's the 0.1, if that's a quarter, then 0.25, that's now a little bit past the halfway mark. I'm sorry, a little bit, let me look, one moment again, 0.25, 0.15. 0.15 and 0.15 is 0.3, correct?
Correct.
So it's actually going to be a little bit before the halfway mark, isn't it? Between 0 and 0.25?
So this would, about half of a quarter, half of 2.25 would be about 1.125, right?
Right, so
Halfway.
slightly at the halfway mark, right?
That would be about 1.125.
Right before it?
So if it was 0.15, would it be like right here?
Very well, but it'd be right before it.
Before it?
A little less before that, right?
Well, if this is 0.125, I'm wondering if 0.15 would be greater than that.
No, it would be less than point. Oh, I see. It would be greater. 0.125. I see what you're saying. Yes, from where your mark is.
Yes, sorry. So yes, it would be.
We can't see. The
it's
0.
hard. Yes, it's hard when we're not in person.
We can write it now.
So right here,
Yeah.
about right there.
A little bit right there.
Yes, I know. It's hard to do. Okay.
9/10 equals 90 hundredths. We, in school, Miss Fishley and I taught the boys and girls the equivalent from tenths to hundredths already.
Mm-hmm.
You should be able to know that 9/10 equals 90 hundredths or 0.90.
Okay.
Therefore, it's closer to 1, and it goes, closer up there. But since 0.3 is 0.75, I don't know if you want to put that up on there too.
Mm-hmm.
Okay.
Absolutely.
And for here, you're going to go closer to the run, but I mean, other than you can't see where I'm trying to mark it on your
Around here?
table. I think so, right around there. Maybe, You don't want to go halfway.
Right.
That would be, I
About
think, be closer to the 1.
so
Maybe slightly. I don't know.
a little
Is that-
closer? Maybe right here?
Yeah.
Is that what? Okay.
I'm thinking 0.75, 0.85, 0.95, somewhere. Yeah, so that would be good.
And 9/10 is almost equal to 1 whole.
1.
Right.
Right.
Exactly.
So this is close to 10/10.
Good. Okay. Excellent.
Okay, 3/5 is a tricky one. It's a little more than 1/2, my benchmark, which is 1/2.
Mm-hmm.
And the reason I know that is 2.5 plus 2.5 gives us 5.
Mm-hmm.
And so for some of you, if you're thinking of like cookies, you're thinking of 5 cookies, you'll each get 2 wholes and half of another.
Mm-hmm.
Okay? So 2.5, it has to be a little more than 2.5. So you're going to look at greater than a half. It's greater than a half.
Okay.
Okay? Or 0.5. And I know that that's a dividing line. 3 divided by 5. 3/5 is 3 divided by 5. So if you could actually show them once, can you show them on the board how you can use that and think of it like a divider? 3 goes into 5, or goes into 3, right?
Oh, 3.
I'm sorry.
Gotcha. Mm-hmm.
There you go.
Okay.
Yep. And then 5 goes into, you're going to actually put a 0 down there. You might have to erase that, what's above there.
Yeah, I'll start over here. Okay.
Okay.
Okay, 0 times. Yep.
Okay, put a 0 there, a decimal and a 0. On the bottom, next to the 3, also, put a decimal and a 0 there. Boys and girls, if you're looking at that as a dividing line, 3/5 is 3 divided by 5. And if you look at that, we always say, even though it's a 3, there's a decimal point there. And now you can think of it, if you know how to divide, 30 divided by 5, and that's 0.6, because 5 times 6 equals 30.
Okay, very good.
Okay?
Yep.
So we want to put that on the number line, and it's going to go after the 0.5, but not even at the halfway point of 0.75. Can't go half. So you're going to think about
closer.
maybe if you could label the 0.75 above.
Okay.
3/4 so they could see that.
Mm-hmm.
Can't see your decimal point real well.
This one?
Yeah, thanks. Just
Yep.
Okay. 0.5. That next dot halfway would be what? Well, it should be a little bit less than halfway. 0.6, correct?
Right. So this would be more, halfway would be about
0.65.
2 maybe, right?
Okay. So it's going to be a little bit before that?
A little before that. Yep.
And then you can label that one 3/5, which equals 0.6.
Which is equal to 0.6.
Okay.
Excellent.
Thank you so much.
Thank you, Mrs. Rex. That was so fun to
This took
hear.
so long.
No, that's great. It's wonderful thinking. We
All of the
appreciate
boys
it.
and girls will get a chance to look at this.
I hope so. All right.
Maybe one of them will get to do it with you sometime.
I would love that. All right. Have a great rest of the day.
Okay, you too.
Okay.
Bye, boys and girls.
Bye.
Let's multiply 4 times 80. So we can look at this a few ways. One way is to say 4 times we have the number 80. So we have the number 80 one time, 2 times, 3 times, 4 times. 4 times we have the number 80. And we could do this computation, add all of these, and get our solution. But let's look at it another way. Let's try to stick with multiplication. And one way we can do that is to break up this 80. We know a pattern for multiplying by 10, so let's try to break up this 80 to get a 10. So if we have 4 times, and instead of 80, let's say 8 times 10. Because 80 and 8 times 10 are equal. Those are equivalent. So we can replace our 80 with 8 times 10. And then we have this times 10 back here, which is super helpful because there's a nice neat pattern in math that we can use to help us with the times 10 part. So let's start to solve this. 4 times 8 is 32. And then we still have 32 times 10. And then we can use our pattern for multiplying by 10, which is that any time we multiply a whole number times 10, we take that whole number, in this case 32, and we add a 0 to the end. So 32 times 10 is 320. And there's a reason that pattern works. We went into it in another video, but here just real quickly. 32 times 10 is 32 tens. And we can do a few examples. If we had, say, 3 times 10, that would be 3 tens, or a 10 plus another 10 plus another 10, which equals 30, our whole number with a 0 on the end. If we had something like 12 times 10, well, that would be 12 tens. And if we listed out 10 12 times and counted them up, there would be 120. It would add up to 120, which again is our whole number with a 0 on the end, our 12 with a 0 on the end. So we can use that pattern here to see that 32 times 10 is 32 with a 0 on the end. Let's try another one. Let's do something like, let's say 300 this time. We'll do hundreds instead of tens, times 6. Well, 300 we can break up like we did with 80 in the last one, and we can say that 300 is 100 3 times, or 100 times 3. And then we still have our times 6 after that. So these two expressions, 300 times 6 and 100 times 3 times 6, are equivalent because we replaced our 300 with a 100. And then from here we can multiply. And let's start with our one-digit numbers. Let's multiply those first. 3 times 6 is 18. And then we still have 18 times 100, or 18 hundreds. So we can write that as 18. And then to show hundreds, we'll put 2 zeros on the end, or 1800. Just like up here, just like we saw that 300 is equal to 3 times 100, or our 3 with 2 zeros on the end. Well, same thing here. 18 times 100 is 18 with 2 zeros on the end, or 1800s. So 300 times 6 equals 1800. Let's try another one, but this time let's go even another place value and try thousands. Something like 7 times 7,000. So like in the previous ones, we're going to break up our thousands. 7,000 is the same as 7 times 1,000. 1,000 7 times. And we still have our times 7 in the front here to bring down. And again, we can multiply our single digits first, our one-digit numbers. 7 times 7 is 49. And then 49 times 1,000 is going to be 49,000, which we can write as 49. And this time, maybe the pattern's becoming clear, we're going to have 3 zeros on the end. So it will be a 49 with 3 zeros, or 49,000. Just like up here, 7 times 1,000 was a 7 with 3 zeros. 49 times 1,000 is a 49 with 3 zeros, or 49,000. Let's look at this as a pattern. If we show this as a pattern, let's do something like 9 times 50. And then in another one, let's do 9 times 500. And in one last one, we can do 9 times 5,000. I encourage you to pause here and see if you can work these out. See if you can come up with solutions for these three expressions. And now we can work them out together. 9 times 50 will be the same as 9 times 5 times 10, because we broke up our 50 into a 5 times 10. And then if we multiply across, 9 times 5 is 45. And to the end, we're going to add 1 0. The pattern for times 10 is to add 1 0. We can keep going here. 9 times 500 will be 9. And then times 5 times 100. 500 is 5 hundreds, just like 50 was 5 tens. Multiplying across, 9 times 5 still equals 45. But this time we will add 2 zeros to the end, or 4,500. And finally, 9 times 5,000 will be 9 times 5 times 1,000, because 5,000 is 5 thousands, or 1,000 5 times. Working across, 9 times 5, 45. And this time we add 3 zeros. So 45,000. So when we multiply each of these expressions, we can see the only thing that changed was the number of zeros on the end. So the pattern, anytime we multiply a whole number times 10, we add 1 0 to the end of our number. Anytime we multiply a whole number times 100, we'll have 2 zeros, and times 1,000, we'll have 3 zeros. And once we know that pattern, we can use it to help us with questions like this, where initially we don't see a 10, a 100, or 1,000, but we can get one. We can break up or decompose these numbers to get a 10 or 100 or 1,000 to help us solve the problem.